Hey all, this is Mr. P, and today we're going to learn about Newton's first law of motion. Okay, let's go ahead and get started. The version of Newton's first law that I prefer is an object will remain moving uniformly unless acted upon by an unbalanced force. Let's take a second and kind of construct that statement. So first, it says the object's moving uniformly, and so that means at a constant velocity, unless acted upon by an unbalanced force. So if things are balanced, like let's say if you had 5 on one side and 5 on the other, then they'd be kind of equal on both sides, or unbalanced would be extra force on one side compared to the other. So simply stated, this rule is saying that constant velocities are associated with balanced forces, and non-uniform motion or acceleration is associated with unbalanced forces when you have more force on one side than the other. One thing you might notice about this version of the rule is that it's a little different than what you might typically see. So typically folks say something like an object at rest will remain at rest unless acted upon an unbalanced force, and it goes on, but I didn't talk about anything at rest. So let's try to take a second to think about if my version of the rule is the same or different than what you could find in a lot of textbook. So let's say, for example, that we have a table, and on the table there is a pencil. So there's a beautiful pencil. My question for you is, as the pencil is sitting on the table, how fast is it moving? Well, I think you would agree that the velocity of the pencil while sitting on the table is 0 meters per second. But now I ask you again, what about now? How fast is the pencil moving now? Well, once again, I think that you would agree it's still 0 meters per second. And if I kept asking you the question, I think we would still agree that as long as the pencil was sitting on the table, its velocity is 0 meters per second. So what I think is worth noting here is that 0 meters per second is staying the same. It's not changing. And so that's a uniform motion. It's a constant velocity. And according to this rule then, since the motion is uniform, then the forces must be balanced. So both up and down and left and right, if there are any forces, they should be the same on one side as the other. That's what this rule is saying. And so hopefully you would agree that this version of the rule can absolutely say what's going to happen for an object at rest. But I think I prefer this version of the rule because it emphasizes what's hard about this. No one has a hard time realizing that if something's at rest, the forces should be balanced. That's very obvious. But what is less obvious is that if something is moving uniformly, then still must be balanced forces on it. So if something is moving uniformly, first there wouldn't have to be any forces on it, because if you had 0 on one side and 0 on the other side, that would be balanced. Or it could be like 10 newtons on one side and 10 newtons on the other side. As long as it's moving uniformly, then we know the forces have to be balanced, and that's less obvious. And so that's what I want you to focus on. Okay, let's take a second and set up a situation and see how well you can figure it out. Let's suppose you go to the Lord of the Rings, and there's a big water well that is far underground. Here's the well, a beautiful picture. There's the bucket that's far underground. There's orcs are chasing you, although fortunately, let's say Gandalf the wizard, so here's Gandalf, is able to use magic and is able to get that bucket coming up very, very quickly. So let's suppose at the beginning of the situation, the bucket is coming up at 1,000 meters per second. Again, the orcs are chasing you, and you're in a big rush to get your drink and get out of there. And it's going upwards. So let's say in the middle of the situation, the bucket is still coming up at 1,000 meters per second, and by the time it comes to the top of the well, it is still moving at 1,000 meters per second. We can assume that it was going 1,000 meters per second the entire time it was moving upwards. If we think about what forces act on the bucket, I think you would agree that there's some kind of gravitational force and there's some kind of tension force. But then the question is, and please think carefully about this, according to this rule, so please explicitly think about this rule, we're trying to apply Newton's first law, how does the size of the tension compared to the gravitational force. Okay, so if we think about the free body diagram, we know there's going to be some gravitational force on bucket by Earth. And we know there's going to be some kind of tension force upwards that's on the bucket by the string. But how do we figure out which one is bigger, or are they the same? So according to this rule, the first thing we need to do is figure out what kind of motion is the bucket undergoing. Is it uniform motion, or is it non-uniform motion? Well, since the bucket was moving up at 1,000 meters per second at the beginning, the middle, and the end, and we said that it was going at 1,000 meters per second the whole time, then it's a uniform motion. It's going at a constant speed. And if the motion is uniform, then we know that the forces need to be balanced. So that's what this rule says. If it's moving uniformly, it'll move uniformly as long as there's not unbalanced force. So it is moving uniformly, so there's got to be balanced forces. If the forces are balanced, then the only thing we know, or the only thing we can conclude, is that the tension force must be the same. So this is on bucket by string. And this one must be the same as this one. So it's really important you understand why the tension force has to be the same as the gravitational force, since it's uniform motion, and uniform motion goes with balanced forces. This is the basic idea of Newton's first law.